Okay. Sorry about that. So at the end of last class, we were taking a look at the following problem. Let's give that one a shot. So I don't remember which A, B, C, D that was last time, but we'll just call it A right now. So give it a try and see how it goes. So I'm not sure what your first inclination is. How did you start this problem? What was your first step?
Move the x over.
Move the x over. I think that's a great idea, to move the x over from the left side, from the right side to the left side. So we can subtract x from both sides. X cubed minus x equals 0. And if that was your first step, then looking at this, you're thinking, oh, well, there's a common factor. I can factor out x. Common factor is the easiest kind of factor and always the first one to look for, leaving you with an x squared and a 1. And then as you're looking at that, you say, oh, well, the x squared minus 1 factor is also x times x minus 1 times 1 equals 0. And we said before, if the product of two or more things gives you 0, then one of them has to be 0. So either x equals 0, or x minus 1 equals 0, or x plus 1 equals 0. One of those things has to be 0. So x either equals 0, or x minus 1 equals 0, then x equals 1. Or if x plus 1 equals 0, x equals minus 1. Now, I just want to talk about what could possibly have gone wrong as you were solving this problem, because there is a common mistake that happens, and I'm going to just talk about that right now. It's possible that when you were looking at that, you were thinking, oh, well, maybe I should divide both sides by x. So you divide the left side by x, you end up with x squared. And if you divide the right side by x, you get 1. And then there's a variety of ways you could solve that. You could say, well, if x squared equals 1, x either has to be plus or minus 1, or maybe you brought the 1 onto the left-hand side, x squared minus 1 equals 0. If you factor that, x minus 1 times x plus 1 equals 0. So x minus 1 is 0, or x plus 1 equals 0. So x equals 1, or x equals negative. It's possible that your first step was dividing both sides by x, getting you that. And then you got 2 answers over here. And over here we got 3. So they can't both be right. One of them has to be wrong. The only difference between these 2 answers is this one said x equals 0 was one of the solutions, and this one didn't. Let's try x equals 0 in the original equation. Well, 0 cubed does actually equal 0. So we know which of these 2 is wrong. That one's wrong. The question is, where did we make a mistake? How did we lose the 0? What did we do that was illegal? We must have done something wrong somewhere. Those of you that have recently gone through the super program have heard me talk about this exact question. For somebody who hasn't, do you have any idea of what might be wrong?
Isn't it you can't divide by 0?
That's exactly what we did. We divided by 0 without even realizing it. In the very first step, we tried to take x cubed equals x and divide both sides by x. Well, it's possible that x is equal to 0. And so dividing by 0 is something we know we're not supposed to do. But the point of me showing you this, so this is completely wrong. That's completely wrong. And the error was right in the very, very first step, right there. And dividing by 0 is something that we know we're not supposed to do. We don't write a 0 on the bottom of a fraction, but it's possible to divide by 0 without even realizing you're dividing by 0. Okay. By the way, if you're wondering why I keep looking over there, I'm recording over here and I see your faces over here, so I'm looking at you. Is everybody okay so far? That's good? Awesome. All right, so let's try a problem which may be a problem that you've seen for the first time, and it's going to involve a little bit of trigonometry, which we haven't reviewed yet, but I just want to see how far we can get without, even if you don't remember anything about trigonometry and anything about sines and cosines and tangents, other than the fact that they have something to do with triangles. Let's see how far we can get with this problem just by what we've learned so far. Try that. That might not look like any equation you've ever solved before, but apply the same principles that we've been using. So based on what we've done so far, what was your initial inclination? What was your very first step?
Subtracting by sign.
Yeah, I think subtracting the sign from both sides, making a 0 on the right-hand side. So let's do that. X sine x minus sine x equals 0. And looking at that, what's your next step? Just based on algebraic principles.
Take out sine x.
Well, factor sine x, common factor, the very first kind of factoring you look for. So there's a sine x in this term, there's a sine x in this term. We can pull it out. Haven't used any trigonometry yet, just using basic algebraic principles here. What do you notice when you see this line? What's your inclination? We have this times that equals 0. What do you know?
One of them has to be 0.
Exactly. We're multiplying 2 or more things. We're getting 0. One of them has to be 0. So either sine x equals 0 or x minus 1 equals 0. If you got that far, if that made sense to you, if that makes sense to you now, I think you have pretty good reason to be happy with yourself. And we haven't used any trigonometry yet. All we've used are basic algebraic principles. We've gotten this far. So either sine x equals 0 or x minus 1 equals 0. We turn this equation into 2 much simpler equations. This one's easy to solve. X equals 1. I'll write down the 4. Now, finally, at the end of the problem, we need to know something about trigonometry, which we will review in a little bit, but we haven't gotten there yet. But it's possible that some of you remember something about the sine curve. Where is sine equals 0? At what values of x is sine x equals 0? I'm not saying that everybody's going to remember this right now, but hopefully some of us do.
0.
Yeah, 0. At pi, 2 pi, and so on. Also minus pi, minus 2 pi, and so on. All the multiples, all the integer multiples of pi. So at all of these numbers and 1, that's where we have solutions to this equation. And we were able to get right to the penultimate step, right to the step right before the answer, without using any trigonometry at all, just using basic algebraic principles. So how do you feel so far about this idea that when you use factoring, you want to get a 0 on one side because it's very easy to decide when 2 or more things multiply to give you 0. Last time we looked at the quadratic formula, which was really nice, and you hopefully remember it from high school or middle school. We saw that common factoring is the first kind of factoring that you always look for. Are the principles of solving equalities making sense? Is everybody good? Okay, I see a bunch of thumbs up. Great. So what I'd like to move on to now is something that causes students, generally calculus students, a little bit more trouble, but it's something that a calculus student needs to be good at because we do it all the time. And that's solving inequalities. So instead of equal signs, we're going to have less than signs, or less than or equal signs, or greater than signs, or greater than or equal signs. And we're going to solve these inequalities. Let's start with some really basic stuff just to get the wheels moving. How about we solve, let's say, x minus 3 equals 3x minus that. No. Oh, sorry, that's not an inequality, that's an equality. Let's go like that. Again, I don't mean to insult your intelligence, I just want to get the wheels rolling here. There's a variety of ways you could do this. Okay, now I obviously don't know what you all did, and as I said, there's multiple routes to the answer. I'm going to choose one in particular, just because I want to illustrate a point of something that you already know. I just want to remind you. I'm going to bring the x's onto this side and the numbers onto this side. So I'll subtract 3x on both sides. So I end up with minus 2x over here. And then I'm going to add 3 to both sides. So I'm going to end up with minus 2x is less than, minus 2x is less, so minus 9 plus 3 hopefully is minus 6. Again, let me know if I do something crazy. And then I'm going to divide both sides by negative 2 to get rid of that minus 2 in front of the x. So I end up with x over here, oops, and 3 over here. What's the one thing I have to remember to do with the inequality?
Flip the sign.
Yeah, I want to reverse it. Because when you when you multiply or divide both sides by a negative number, you have to reverse the inequality. Hopefully that's something that you've learned before and you remember, but it bears repeating now, just because it's an easy thing to miss if you're going fast. So hopefully that was pretty straightforward. You can write your answer like this. As an interval, you could write it as 3 to infinity. You could graph it on the number line. Open circle at 3 and then shade in everything to the right. You don't have to put them all down. Any one of these is fine. You can write it out in words. All real numbers greater than 3. It's all good. However you want to write your answer is fine with me. Make sure that what you have on your page is correct. And you should be able to recognize the answer in all those forms. All right, let's try something a little bit more interesting. How about x squared plus 2 is greater than, now let me make it less than 3x. Let's give that a shot. I'm not going to let you quite go to the end, but I want you to start. So just based on what we've done so far, what was your first step?
Minus
One
3.
side equal to 0.
Yeah, I think getting that 3 onto the left-hand side now, that was probably a reasonably obvious first step, something that probably occurred to you. So let's move this on to the left-hand side. We'll subtract 3x on both sides. I'm going to write it in the middle because I'm used to seeing the x squared term and the x term and the constant term. So we'll subtract 3x on both sides. X squared minus 3x plus 2 is less than 0. So far, so good. Is everybody was pretty confident with that step? Is that okay? What was your next step? I think your next step probably gave you a lot of confidence too. What was it?
Factoring.
Yeah, factoring. That left-hand side looks like it factors. Let's go ahead and factor it. So we're looking for two numbers that multiply to give you positive 2, and that's give you negative 3. Well, minus 1 and minus 2 definitely do. Okay, so I'm hoping everybody got this far. This is basically what we do in equality. I'm hoping everybody got this far without any trouble. If people got into trouble, it was probably in the next step. And I'm not claiming that you did this, but it's possible that you wrote down in your next step, you went one more step, it's possible that you wrote something like x minus 1 less than 0, x minus 2 less than 0, and then try to put some sort of conjunction here, and or comma, anything. If you did that, I'm not saying you did, not saying this is what you did, but if you did that, no matter what you wrote in here, the whole thing's wrong. There's no way to get the right answer. It doesn't matter what you write right here. So if that's what you did, then we need to, or if that's what you were thinking of doing, we need to think this through. So before, when we had equal signs, if I had something like x minus 1 times x minus 2 equals 0, we were able to write x minus 1 equals 0 or x minus 2 equals 0 because you know if the product of two or more things gives you 0, one of them has to be 0. This says the product of x minus 1 and x minus 2 is negative. It's negative. Under what conditions is the product of two numbers negative?
One of them is negative. You multiply them.
One of them is negative and the other one is positive, right? If they're both positive, if the product is positive, and if they're both negative, the product is positive, right? The only way for the product to be negative is if one of them is negative and the other one's positive. Does that make sense? All this algebra stuff grows out of arithmetic that you already know. So let's write down what we just said. The only way for the product of these two things to be negative is if one of them is positive and the other one's negative. So either the first one's positive, we just said x minus 1 is greater than 0, positive, and the second one's negative, x minus 2 is negative. Either the first one's positive and the second one's negative, or the first one's negative. So x minus 1 is negative, and the second one's positive. So if we're gonna solve this with algebra, if we're gonna say, okay, well, the product of these two things is less than 0, one of them's got to be positive, and one of them's got to be negative. This has got to be our next line. That's got to be the line we write. Let's have a closer look at this. So this says x is greater than 1 and x is less than 2. Just adding the 1 to both sides here and adding the 2 to both sides here. Or x is less than 1 and x is greater than 2. The conjunctions are very important here. These are ands and these are ors, and they're ands and ors for a very particular reason. Either this is plus and this is minus, or this is minus and this is plus. We're taking what we know about numbers and just writing down some algebra. So let's take a look at this first set of parentheses. Let me just make sure you're finished writing. Okay, you look like you're finished writing. Let's take a look at this first set of parentheses. This says we're talking about numbers which are bigger than 1 and less than 2. Where are all the numbers that are bigger than 1 and less than 2 simultaneously? Where are they on the number line?
In between.
Yeah, in between 1 and 2, right? If a number is bigger than 1 and less than 2, maybe it's like 1.5 or 1.75, anything between 1 and 2. So these are all the numbers between 1 and 2. Open interval 1 to 2. You could write, you don't have to write it like this. You could write it x is between 1 and 2. That's totally fine. You don't have to write both. Either one of these is fine. You could graph it. This set of parentheses says you want all the numbers which are simultaneously, I have an and here, which are simultaneously less than 1 and bigger than 2. Are there any numbers that are less than 1 and also bigger than 2? No, there aren't any, right? I mean, if a number is less than 1, it's definitely not bigger than 2. So this part has no solutions. There's no number that's less than 1 and bigger than 2. I guarantee it. But there are plenty of numbers that are between 1 and 2, like 1.5 or 1.25. So all the solutions here are, you can write your solution like that, you could write it like this, you could graph it on the number line, you don't have to do them all. Any one of them is fine. How do you feel about that? Are there any questions about the solution to that particular problem? Does that make sense? Okay, great. Well, let's just modify this slightly. How about we go, let's change the inequality. X squared plus 2 is greater than 3x. First parts of that are identical, right? Other than the fact that I changed the order of the inequality. So bring the 3x over, almost seems a shame to do all this writing. Greater than 0, and then you factor x minus 1 times x minus 2 is greater than 0. That's all the same. So now, if the product of two numbers is positive, what can you tell me?
They're both negative or both positive.
Exactly, they're both negative or both positive. If you take two negative numbers and multiply them, you get a positive number. If you take two positive numbers and multiply them, you get a positive number. So either they're both negative, so either x minus 1 is less than 0 and x minus 2 is less than 0, or I have to do a little bit of erasing here, or x minus 1 is greater than 0 and x minus 2 is greater than 0. Either they're both negative, either we had a minus sign here and a minus sign here, that's what we wrote here, or they're both positive. And we can simplify these a little bit. So x is less than 1 and x is less than 2, or x is greater than 1 and x is greater than 2. That's already looking a little better. Okay, so this first one here, if I tell you a number is less than 1, and I'm also telling you it's less than 2, what am I really telling you?
X is
Yeah, sorry, go ahead.
Or less than 2.
X is less than or equal to
Less-
1.
Not less than or equal to, just less than.
Sorry, wrong.
X is less than 1. If I'm telling you a number is less than 1 and I'm telling you it's less than 2, by telling you it's less than 1, I've already told you it's less than 2. So this whole thing simplifies to X is less than 1. I'm not giving you any new information by telling you it's less than 2. If I told you it's less than 1,
Question.
yeah.
So if it's less than 2, then doesn't that include 1? Because it's and, it's not or.
Right, it's and. So if I told you, so like a number like 1.5 is less than 2, but it's not less than 1, so I couldn't say both of these things were true. A number like 1 is less than 2, but it's not less than 1. 1 is not less than 1. It's equal to 1. So both these things are true simultaneously. The only numbers for which both are true simultaneously are the numbers less than 1. Does that make sense? Look at your faces. Thumbs up, thumbs down, thumbs up. Anybody have a thumbs down? Okay. Awesome. If that's not clear and you absolutely can't bring yourself to say it right now, feel free to send me a message later and we can talk about it during office hours. Okay, and over here, if I'm telling you that X is greater than 1, and so both these things have to be true, and it's greater than 2, what is true about these numbers if they're both greater than 1 and greater than 2?
It's just greater than 2.
Right, it's greater than 2. Like if I tell you a number is greater than 2, I've already told you it's greater than 1. And there's an or. So here are the numbers that are less than 1 or greater than 2. If you want to write this in interval notation, you could write negative infinity all the way up to 1, and then all the numbers from 2 to infinity. You could graph it on a number line. So let's say 0, 1, 2, 3. It's all the numbers less than 1. It's all the numbers greater than 2. There's lots of ways you could write your answer. You don't have to put them all down. Any one of them is fine. Choose your favorite. So I'm going to wait to make sure that you've all finished copying that down. And is it all making sense? Is that good? All right. Because I'm going to have to erase everything that's on the blackboard, so I want to make sure that it's all there. You got it all? Okay. Because I'm going to need, I think, the whole blackboard for the next problem. So was that C? I think we're on D now. If I'm wrong, let me know. Okay. Let's try this. We're going to have an x cubed on one side, an x on the other side, and that should look familiar. Now let me make it a 4x on this side. And I am going to put a less than symbol. So let's go ahead and try to solve that. Again, the beginning of this should be relatively clear to you now. And at one point, things might get a little hairy. Well, let's give it a shot. This is already quite an advanced inequality. Hoping your first few steps were very clear to you. Bring the 4x over. Hoping your next step was clear to you. Factor out an x, common factor, easiest kind of factoring, first one you look for. Oops, squared is 4. And probably look at the x squared minus 4 and realize that that was difference of squares, so you can factor that. X times x minus 2 times x plus 2 is less than 0. And if you got that far, that's great. Now things get awful. If the product of 3 things is less than 0, in other words, is negative, what can you tell me?
Either 2 of them are negative or just one of them is negative. So the answer is negative.
Good. So if one of them's negative, it's negative. What was the first thing you said?
If 2 of them are negative.
If 2 of them are negative, then it's going to come out positive. If 2 of them are negative and 1 is positive, the 2 minus signs.
Oh, yeah, I'm sorry.
I think what you meant to say is if all 3 of them are negative. If 3 of them are negative, then it comes out negative. So if one of them is negative or all 3 of them are negative, it comes out negative. If they're all positive or 2 of them are negative, it comes out positive. So either one of them is negative, so either the first one's negative and the second one's positive and the third one's positive, or the first one's positive and the second one's negative and the third one's positive, or the first 2 are positive and the third one's negative. So either we have one negative or all 3 of them are negative. So let's go ahead and write that out. So either the first one's negative, x is less than 0, and the other 2 are positive, x minus 2 is greater than 0, and x plus 2 is greater than 0, or the first one and the third one are positive and the middle one's negative, x is negative, oops, x is positive, and x minus 2 is negative, and x plus 2 is positive, or, this is already looking awful, the first 2 are positive and the third one's negative, x is greater than 0, and x minus 2 is greater than 0, and x plus 2 is the negative 1, or they're all negative. X is less than 0, and x minus 2 is less than 0, and x plus 2 is less than 0. All we've done is write out the 4 possibilities that we said we had. Either exactly one of them is negative, which gives us 3 possibilities, or they're all negative. And I don't know about you, but to me that looks like a nightmare. I'm looking at your pictures, I'm looking at the pained expression on your faces, but it looks like you're mostly finished writing. So we can simplify a little bit. So this says x is less than 0 and x is greater than 2 and x is greater than negative 2. Or x is greater than 0 and x is less than negative 2 and x is greater than oops, x is less than 2, I should have said, and x is greater than -2, or x is greater than 0 and x is greater than 2 and x is less than -2, or x is less than 0 and x is less than 2 and x is less than -2. Which perhaps looks marginally better, but still abysmal. Okay, so we have 4 sets of parentheses here. Let's reason out what's in each of these. So if x is less than 0, it's a negative number, and it's greater than 2, I guarantee there are no negative numbers that are greater than 2. So this first set of parentheses doesn't lead us to anything. We don't have to worry about that. This says that x is positive, it's a positive number, and it's less than 2, and it's also greater than -2. Well, I already knew it was positive, so this doesn't tell me anything, but I have all the numbers here between 0 and 2, not including 0 and not including 2. So x is between 0 and 2. That's what this one gives me. This third set of parentheses says we have a positive number. I'm going to leave that for a second, but it also has to be less than -2. There are no positive numbers less than -2. So that doesn't give me anything. And this last one, x is less than 0. Okay, it's a negative number, and it's less than -2. Okay, so I know more about it now. Not only is it less than 0, it's also less than -2, so its number is less than -2, and it's less. Oh, sorry, it's less than 2, and it's also less than -2. So it's got to be less than all those numbers. It's got to be less than -2. So x is less than -2. So I could write my answer like this. X is less than -2, or it's between 0 and 2. I could write it like this. I could write all the numbers less than -2, so that's -infinity all the way to -2, and also the numbers from 0 to 2. Or I could put it on a number line. -3, -2, -1, 0, 1, 2, 3. So it's all the numbers less than -2, not including the -2. And it's all the numbers between 0 and 2 also. And if you're going to solve this problem using algebra, this is the method you have to do. If you just wrote at this step, x is less than 0, x minus 2 is less than 0, x plus 2 is less than 0, there's no way you can get that answer. That's completely wrong. This is complete garbage. It doesn't work that way. It's not true that if the product of 3 things is negative, all 3 of them have to be negative. One of them could be negative. You know that. Okay, but there are words which I hope are going through your mind right now. Very important words. And the words are, there has got to be a better way. If we're going to be doing these things all the time, do I really have to do this every single time? And the answer is no. If you're going to solve it by algebra, this is how you have to do it. But there is another way that you learned in a course with a different name than algebra. Your course in high school might have been called functions, it might have been called mathematical analysis, it might have been called pre-calculus, but basically it was a course in functions. So this is how to solve this problem. With algebra. If you're going to solve an inequality with algebra, these are the steps you have to go through. But we have another method. We have a different way to solve this problem. Using functions. You've done a lot with functions over the past, perhaps, year or 2 years of your life. So remember the idea of functions. Let's say I give you a function, something like f of x equals, let's say, x squared minus 1. You know that this function is like a machine. I can put a number in, like if I put the number 5 in, then what comes out is 5 squared minus 1, 25 minus 1 is 24. So a number goes in, a number goes out, a number comes out. The important point that we're going to use now is that we can, that a function has a graph. In this case, y equals f of x, which is just x squared minus 1. That's probably a curve that you recognize because we just start off with the curve y equals x squared, which I'm pretty sure everybody recognizes as a parabola. And then you shift it down 1 unit. And so the graph of this thing is just the parabola shifted down 1 unit. I'll just tell you across at the x-axis at -1 and 1. I just recopied that. But, no, you're still writing. The salient point at this step is to realize that sometimes, for some values of x, this is above the x-axis. In other words, it's greater than 0. For some values of x, it's below the x-axis. In other words, less than 0. And where it goes from being greater than 0 to less than 0, or less than 0 to greater than 0, it crosses the x-axis. It is equal to 0. And we are going to exploit that to be able to solve equations like this without all that horrible mucking about with algebra. We're still going to have to do some algebra, but those last few steps that look terrible, we're going to see if we can avoid those. So is that making sense so far? Well, we haven't actually done this technique yet, but we're going to. So everybody understand what our goal is to make our lives less miserable? Awesome. In that case, Have a good weekend. I will post the third homework, so it will be up at some point today. I will. Sorry about Wednesdays, didn't go up till Thursday. I forgot to press save. I will not make that mistake again. At least not today.